This is Pete Tseronis here, and I'm excited today to have a guest that by the time we're done, you're going to be awfully educated, informed, and enlightened. He is an incredible mind in the world of energy and innovation and critical infrastructure. Ed Rhyne, Senior Technical Advisor at the U.S. Department of Energy within the Office of Cybersecurity, Energy Security, Emergency Response, which was a mouthful. Ed, welcome to the show.
Thanks, Pete, and thanks for having me. I appreciate the opportunity.
Yeah, brother, I am excited. I'm going to do a little bit of bragging about you because I promise, even though I'm looking down, I don't want to read your bio because it's beyond impressive. I actually have a page and a half of information here, but the hope is that we will cover a bit in your bio, which will cover a lot of what we're going to talk about, both you as a leader and also as a strategic and operational and tactical influencer. So, Ed, 30 years, you've been working in areas around systems engineering, technology development, program management. You're currently at the Department of Energy within the office that we talked about, and we'll get to that mission because I think there's a lot going on in the title. You're leading threat mitigation portfolio topics such as cybersecurity for operational technology environments, consequence-driven cyber-informed engineering programs. Again, a mouthful, but awfully compelling. Prior to DoE, you worked here over at the DHS in the Office of Science and Technology. You led the Domain Name System Security Program, the Innovative Science and Technology in Counterterrorism. That's a cool acronym for INSTINCT, folks. The BioAgent Autonomous Network Detector Band, if you will, program. We'll get into maybe some of that because that's been part of his formation. But Ed, I really think what I like to call the walkabout and how you have just traversed through government and in private industry where you have some very interesting influence as well. You've worked at DOE, you're at DHS, you have your Johns Hopkins University where you spent almost 5 years in their applied physics lab and numerous engineering roles. NASA, he comes to us by way of Case Western, Penn State, and Johns Hopkins. So that's my version of, folks, Ed Rhyne. And Ed, within that, seriously, I think your engineering roots and your opportunity, as you've done for me over the years, has really helped shape the discussion around a world that is so digitally connected. And we're so dependent on the internet and industrial internet of things. I will caution you in advance to maybe have to sometimes explain when I say critical infrastructure or national critical infrastructure functions and that sort of thing, that you help shape and, as I like to say for our audience, educate a bit on the significant role that the department plays, but more so its relationship with other agencies in the energy sector.
Sure.
Cool. Okay. So Ed, other than what I mentioned, easy softball coming at you. How has your journey from college, from the university to where you are now really shaped and formed your leadership and your views of the world?
Easy question. So actually coming out of school, worked at a small mass spectrometry company, mass spectrometers, and designing, building, installing, basically all over the world. And that gave me a lot of opportunity to, not only get into the digital control, we also did analog back then, but also, learning the physics of, what we were actually trying to do. What was the problem that was trying to be solved with, mass spectrometers? And, everything from, public health, how does the body respond to certain bacteria to, even material science. And, having that kind of bridge between, the analytical chemistry and then what was that being used for in the real world was actually quite beneficial, especially early on in my career, because then as, I progressed through, like with Hopkins and, DHS and DOE, always having that base to, what are we really trying to accomplish with this really cool technology? Technology for technology's sake is not, where we need to be, especially now. And I was very fortunate coming up through, at that time with, the digitization of the world, and now we're in the electrification of the world effectively, with transportation and everything else, so having all of these things kind of fall into place for me was actually quite beneficial and opportunistic in a way.
Yeah, well, agree. And I really want to just emphasize again that engineering and scientific brain that you have, aside how important that is, as you mentioned, what underpins the 16 critical infrastructure sectors and the 55 functions, and ultimately the cities and communities. I mean, Ed, we're going to jump into, having you describe your views of CSER's role. It's a fairly new agency or office within the department, but it's got a lot going on: cybersecurity, energy security, emergency response. Why don't we pivot to that for a minute and just talk about the mission? I mean, folks, you can go to energy.gov and read about what it is, but Ed, in your eyes, and again, where you sit, how have you seen the organization from day one and its evolution and the value it's bringing to the energy sector and other sectors?
Yeah, so there's several functions within CSER. As you mentioned, the cybersecurity is one, and there's kind of multiple elements to that. There's the operational cyber, so the situation awareness and looking to see, how the energy flow is actually being affected across the sector. And it's not just electricity subsector; it's also oil and natural gas. So, energy, Department of Energy being the sector-specific agency for the energy sector, has all of this, kind of mission space. So the operational cyber is one element, but we also do R&D. So cybersecurity for energy delivery systems, and the R&D is actually critical because trying to make sure that the energy flow is well, let's say predictable, and going when it needs to go, where it needs to go, and how it needs to go is critical, and as we move more and more into, the digitized world, and there's more and more opportunities to, say remote access, other things, you need to really make sure that energy flow is exactly what you expect it to be.
Yeah, you and I talked a lot leading up to this about energy flow, and again, it could be as simple or as complex as you've said, and it's what I really love about talking with you. And you, Ed, you really are an educator. You can take something that's really tough to even read and say, oh, that's what it's all about. So energy flow, distributed energy, R&D, research and development. There's so much going on in today's day and age around grid modernization, obviously cyber physical systems. These again are terms that we know represent the world we're moving into. I like to tell folks, hey, we talk about zero trust and supply chain and at the edge and the cloud and the devices. We depend on the things we don't see: Wi-Fi, spectrum. So having folks like you in our nation really looking at how we're going to prepare for the new threat landscape is tremendous. Can you speak to that specific component? When you say R&D, how is CSER orchestrating, or maybe if it's even as much as I saw on the website, funding opportunities and the relationship with the utility sector? And I don't just mean energy. How is that collaboration working?
Yeah, so there's kind of multiple efforts. There's the operational, which is much more of the nearer term. What can we do to help, the entire sector, understand and know where their role is, not from a, hey, my job for my organization is to move the energy. Absolutely. But there's, sector trend analysis that we need to do. So there's situation awareness for the entire sector, that some of the operations side, really has to look at. And it's not just, again, cyber, it's, the hurricane response. It's, think natural disasters. It's the all hazards approach that, quite frankly, are, not completely separate from cyber. So if something happens, if there's a natural disaster, you can't just forget about the cyber, because that's an opportunity for somebody to do something bad on the back end when you're looking over, to the restoration part of the mission, to perhaps neglect the security side, and bad things can be dropped in behind, when you're not looking. So, we really have to make sure that all that's coordinated and work with the utilities so that there's, obviously there's understanding, but, what can we do about it? From a, how can the government help the private sector? Because the government doesn't own necessarily the infrastructure. So we have to make sure that the right incentives, the right knowledge base is there so that everybody can benefit from the fact that we all need energy.
Yeah, no, that's well stated again, and I want to emphasize what I hear, and that's again, it's a collective effort, right? Academia, government, industry, startups, the folks that could be in a garage, as I like to say, that might receive a grant fund or funding from a grant that can invent something to provide analytics to look at threat intelligence on the grid. That was again a lot, but there's so much that you, I know, are at the nexus of both in Caesar, but also in your experience. Let's go
right,
to
but that guy in the garage, Pete. So that guy in the garage, though, I mean, he might actually have the next idea as to how to make things better in the future, and that's the other part of the Caesar mission. Especially with the R&D. There's the near term, what can we do for the asset owners and the energy sector companies today, but then also what's the future? What's the energy security future that we believe we need to get to? And then how are we going to accomplish that? And that's really when we need to focus some of our R&D efforts on, whether that's, looking at, being the consumers of, AI and ML, the artificial intelligence and machine learning algorithms that are coming out, building, working with the vendor community on, the equipment that actually moves the energy to build the digital twins or the digital ghosts, so that we can use, their knowledge of how the system's supposed to work with the asset owner's environment of how they believe their energy is moving to build the AI, so that if something does get disrupted, they're able to buy some time by putting the counter signal in to make sure that energy flow is continuing, so that we can go find out, okay, why did that happen? Is that a coincidence, like a relay was going bad? Or was it a correlated event where somebody was actually driving that relay, faster to switch than it needed to, and then it started to go bad?
Okay, so now you're taking me off my entire thought process because I'm
Sorry.
a stream of consciousness. No, I love it. And again, I think, Ed, you're just doing what's natural, and that's showing your brilliance and also your just passion for this space. I'm going to get to the Coyote program, which again, cool acronym. But you said something, and I hope the audience catches that: digital twins, digital ghosts, replicating what we're learning from those cyber physical systems. Folks, natural disasters happen. I can list 5 off the top of my head, but take Katrina, take Superstorm Sandy, take the floods this past year up in the northern part of the country, take Fukushima. We learn how physically at risk we are. And resilience is a word that Ed's taught me to get in my vocabulary quite often. And it's different from a liability, but it includes things that is we need to respond quicker. We need to invest in technologies, and we have to leverage that entrepreneurial spirit, because cyber physical is something that is synonymous with next generation grid and sector innovation. So Ed, I want to go to the Cybersecurity for Operational Technology Environments program, Coyote. But I'd also ask if you can, again, this isn't meant to be a coming out of nowhere, but the IT/OT discussion, there's always the wait, IT/OT. Can you talk about that symbiotic relationship? Because that sometimes confuses folks.
Yeah, sure. So, I mean, IT, information technology, mostly known for, being in enterprises, and, your desktop, your email system, all that is your IT. Your VPN connections into, for remote, everybody's remote working, when things happen. So, that's all what I would consider IT. OT, though, is going into, more of the embedded processing, the systems that, in the energy sector, that actually move the energy, so the relays, the
synchro
switches. Exactly. Yeah. Thank you. So all of the things that actually are, systems that generally you don't log into, so you're not going to be browsing the internet from them. Generally they don't, you don't have a lot of interaction with them. There's the safety systems in there. The things that actually make the energy flow, from generation through transmission into distribution. So that's what I would consider the OT environment. Now, because we've started, a lot of digital control, there's a lot of intersection between the IT, so you're sitting in an office space, but you want to control, say some facet of a substation for, load balancing or whatever. How are you going to do that? Well, you can do that either at the substation, or you can do that remotely from, an engineering workstation, let's say, and, bridge that gap between IT and OT. And that kind of interface there, through, a DMZ or other, technologies with jump boxes, whatever, that is where I draw the dividing line between IT and OT.
Okay, so we're going to go right into Coyote, but I'm going to just do what I love to do for myself, but hopefully those who are Joe and Joanne six pack. Cyber physical systems, critical infrastructure. I Googled industrial control systems, Ed, and what came up was SCADA, distributed control systems, and programmable logic controllers, I think. And to me, that was like the four, like, yes, there you go. So you, and there was a shout out, there is a shout out to you that at least NIST, when I looked up the definition of cyber physical, and I quote this, interacting digital, analog, physical, and human components engineered for function through integrated physics and logic. Now, maybe that's why we have acronyms, but that actually spoke to me. So thank you for that explanation.
Sure.
So let's pivot to that program, this great program. And I know we might hit on a couple others, Ed, and feel free to jump in with the CRISPs and the CAT 2.0s or what you can share publicly available on websites. But Coyote, what's it focused on, and what excites you about its evolution?
Yeah, so Coyote is, the cybersecurity for OT environments, and it really is looking at from that boundary, between your IT and your, functional part, the part that's actually moving the electric, the energy, and how does that actually work? And because we're moving more and more digital control into that environment, how are we going to protect it so that, the energy flow is predictable, it is going where we want, when we want, and how we want. That is, a challenge, both in IT and OT. And, I look at the OT space as kind of flipping the IT world on its end, because if you think about the IT, you've got, fairly finite, protocols. There's certain protocols that you're going to be using from your desktop, whether it's web browsing or mail or whatever. But there's infinite behaviors because you've got the guy on the keyboard that you don't know what their logic is. They're going to do whatever behavior they, believe is necessary for them to get their job done or do whatever they're trying to get done. And on the OT world, though, things are much more stateful, much more defined. You've got a relay; it can either be on or off. So there's much more, shall we say, defined state, that you can model or predict as to what's going to happen. But on the flip side of that, there's almost infinite protocols because you got vendors that are implementing potentially even standard protocols, but in different ways. So you've got, kind of the opposite problem, that the IT world does, where they've got very finite protocols, but infinite behaviors. In the OT world, you've got finite behaviors, but infinite protocols effectively.
Wow. Yeah. That just did it for me. Light bulb moment. And again, you've shared with me too, this, think of it as purpose-built control systems. They've kept the country up and running for over a century, but this IT world now, it's exciting, but also more threat has been introduced, the cyber side.
So Coyote's looking at that statefulness, if you will, the fact that, there are, it's based in the physics again, so the OT world is supposed to do certain things and, at certain times, so what Coyote is doing is taking the fact that, you should have a very good understanding as to what your environment's doing. And we have to work very closely with the asset owners because they know what their models are as far as their energy flow. And what we're asking them to do is look for anomalies, however small they are, however obvious, at first blush they are, take those as what we've been calling triggering events to then start to build the communication path to that device, so that, oh, well, this relay was talking to this gateway, which is talking to this substation, which is talking to, all the way back to, if you can bridge that DMZ zone, great, awesome. Go all the way back to where you can actually trace that communications path. Because if it goes past an engineering workstation, there's probably a problem. Why would somebody from a, pick your favorite non-engineering department in a company be controlling, something in an OT environment? It just shouldn't happen. So if we can get all that communication path, which is, highly unlikely, but, that's kind of what we're going for, is looking at the physical anomalies, the things that the company says, hey, this is odd. And then looking to see, is there a communications path that was driving that? Again, kind of answering that question of correlated versus coincident.
So when I think of your world and whether it's helping to facilitate bringing in a lot of this knowledge from industry to collaborate with the department, we hear that a lot about, public-private partnerships. When I think of Caesar, and again, I'm asking you to articulate this for anybody saying, I would love to work, partner, do what have you with them. What is a typical protocol? Is it go to grants.gov? Is it go to the funding opportunities on the website? Because How is someone to know what the challenges are that Caesar's trying to facilitate or solve?
Yeah, so from the R&D perspective, so if you've got an idea that you want to help develop, or you want to, you want to actually have help being developed, uh, then there's opportunities. So there's funding announcements and other things that Caesar publishes, for funding opportunities.
Okay.
Now, if you're an asset owner and you've got, let's say a problem that you need, solved, or you've got data that you think can contribute to the development of a tool that, we're working on or should be working on, there's mechanisms in place with your own, ISACs, Information Sharing Analysis Center, or the sector coordinating councils to bring that, opportunity to us.
So there's plenty of bodies, and you mentioned a few, the ISACs, and I think sometimes there's like a little bit of a quagmire of where do I go? There's a well-intentioned information sharing happening.
Yep.
It's just a matter of, like you say, I think correlating and just getting involved. So
yeah, but I mean, the direct route, just coming directly to us, is always option. So we work very closely with, many utilities, whether they're, the investor owned or the muni and co-ops.
Okay.
So we do work very closely with industry.
All right. Some of this is for later when you get to put on your vision hat, but given you were talking R&D, I always like to go. And folks, again, research and development, the Department of Energy, we've mentioned labs, but it's not just the national labs that Ed's referring to. The whole academic environment, the asset owners, the owners and operators of the infrastructure have brilliant people working there and in those utilities, if you will. And they're always trying to improve the delivery, or as Ed, you said, the energy flow, but also doing it in a risk mitigating manner, which is where Ed, I feel, in his vision and where he works comes into play. So get involved. Are there some specific exciting things you're seeing? You mentioned, the digital twins and the digital goes. What excites you a bit about some of what you're learning that's happening in R&D? Publicly available. Don't share any secrets.
Yeah. So, I think, you mentioned the digital ghost and digital twin. I think having the manufacturing community, the vendor community that's actually building the equipment work with us to develop those models, and then working with the asset owners to develop their models of how they're using those. So you build this incredible, digital model effectively as to how things are supposed to be running. And then the better fidelity we can get coming out of that model, the smaller the actual changes are that we'll be able to detect. So then we can start saying, oh, well, this doesn't make sense. And then you couple that, with the, the emerging, AI and ML algorithms that you can put into place and say, well, can we actually start to affect change, and have these kind of self-aware, self-healing delivery systems, energy delivery systems, so that we can have kind of this ability to power through in the face of an attack or, even a natural disaster, to where we're much more able to, so we say, avoid the problem.
Yeah. And Ed, I failed to mention it, but I think it's a perfect time to bring it in. Forgive me when I was bragging about you in the only way I know how, and that was not reading your bio, but sometimes I overlook one or two things. When I was at the Department of Energy and I was the chief technology officer there for a while, I had a wonderful time canvassing the national labs, going to the tech transfer commercialization sessions, and cyber physical was still burgeoning. I mean, this is 2009 for what it's worth. 10 years ago, we're talking smart grid, but people are like, smart what? I get to work in the smart cities and communities domain, so a lot of the work you're doing, I celebrate and feature wherever and whenever. But you at one point were also working with or collaborating in your non-government life, right? With some of this equity, private sector space and communities. And what was that experience like when you reflect on the kind of questions that they had beyond, oh, I want to invest in the next thing of the future? It seems like you had an opportunity then and now, again, with your time at DHS, to really educate that community on sort of the greater good. Can you comment on anything and what that was like?
Yeah, so I did have a very nice opportunity to work with an equity fund, and they many of their partners were actually utilities and asset owners. So having the opportunity to hear directly from them, here the challenges that we have, that we need solutions to, and then having, very similar to, government R&D, where you've got, people coming in and pitching, ideas, being able to sift through all the different options and say, okay, here's some, good solutions. And then looking at, okay, well, does it make sense for an investment? What's the size of the market? Is it something that's going to be, necessary or nice to have? Is it regulated? Is it not regulated? And then figuring out, okay, what's the incentive structure? Is there a business, plan that actually makes sense, for these technologies? And, that opportunity was phenomenal from, my point of view, from a, an R&D, tech guy that, I'd be happy to just get lost in the tech, but, the application has to be there as well. And, having that kind of immediate feedback with, the folks that have to implement it with the asset owners, that was invaluable. And hopefully I, was able to give them some value too.
Yeah, well, I'm sure you did and continue to do so, and it's just what an opportunity to be on both sides, and that's good, great feedback actually, and insight. So Ed, let's go back to some of your other roots though. DHS, you spent a good bit of time there. I mean, I was looking at, you were S&T program manager, you were JHU Applied Physics Lab with biological sensors. You've had all these engineering roles in NASA. That's very technical and very, what I call, wonderfully, it's a comment, geek speak to the ins and outs, the binary stuff, the ones and zeros, and developing what will underpin our cities and communities of the future. Can you share maybe for the group that understands or thinks of, well, doesn't DHS do all the S&T stuff, and what's energy doing in that space? Can you kind of just maybe educate folks on how much collaboration happens and maybe some of your experience at DHS?
Sure. Yeah. So there's a lot of collaboration. So DHS does have, a very significant role, especially talking about critical infrastructure and national critical functions and all of that space. But the sector specific agencies, they have the good relationships with the sectors. They're supposed to have the domain knowledge, whereas DHS is, to me, more of a coordination role for the cross sector analysis. So you mentioned the industrial controls, SCADA systems, PLCs, those aren't unique to any one specific sector. So, pick your favorite critical infrastructure, they're going to have the same components, probably, applied differently, let's say, different algorithms, different, physics of their sector, but, similar problems, similar issues that need to be resolved. And that's where I see DHS being able to say, oh, there's something happening over here in the energy sector. Or we know that there's, this very broad attack that's happening. Is that something that could then pivot to other sectors? And that's where I see, the DHS role. Now, I might be wrong, but that's kind of where I was looking. Yeah.
No, I love it. And again, I'm going to do this if I can have a minute here, half a minute is, we mentioned, we're talking about critical infrastructure sectors, which if you go look on dhs.gov, folks, you'll read about its definition. And then there's these national critical functions, which are really a subset of, these are the sectors that are power or energy and manufacturing and water and wastewater and the things we depend on. I like to call it the planes, trains, and automobiles and things that we use and drink and bathe in. And we want to make sure that those sectors, and hope that those sectors are being protected by places like, the departments of fill in the blank and the asset owners and these national
and that they're working together.
Yes, and that they're working. Yeah. The definition, a complex interconnected ecosystem. That's about as simple as I broke it down to and said, well, that is it. And then the national critical functions, I loved when it, again, was described as electricity generation that powers homes and businesses, transportation of commodities and people, and access to GPS data for cellular networks. These are the functions we depend on, right, Ed? And securing those in a cyber and a physical manner are really where I feel like Caesar's leading the way. And shout out to you and all the great work you're doing in that space. So let me ask you this next question. Caesar, Department of Energy, what's the relationship of Caesar with the Office of Electricity? Because if I'm not mistaken, the Cybersecurity and Energy Delivery Systems was once a part of that office, correct?
Yeah, in fact, both elements of Caesar came out of the Office of Electricity.
Okay.
And inside ball, we literally just, made them completely separate organizationally. So we were actually leveraging a lot of the resources within the Office of Electricity, for the first 2 years.
Yeah.
Yeah.
Yeah, and I only mention that because when I was there, bringing it personal here, it was what a Office of Electricity covered so many areas. But and I think
Mhm.
in light of the world we're living in now, cybersecurity, the R&D, and how we protect those through the ISER program, the infrastructure, security, emergency response. Did I get that right? Oh,
I believe so. Yeah.
all right.
Yeah.
The day-to-day operational, I think it's very unique and special in that regard that there's such a focus. Okay,
Yeah.
so Ed, I get to work, I mentioned, in a lot of the smart infrastructure world, the smart cities and communities. And again, to emphasize what is the plumbing of the internet or the IT world and the OT world, the infrastructure, supporting the sectors. Do you have any exemplars of cities and communities and or technology specific outside of saying AI and ML, but are there some really exciting things that folks can go learn or read, or maybe just a resource on what we're seeing that's tangible as a result of a lot of the R&D, and give us some hope?
I think, you mentioned a lot of the interdependencies, so when you mentioned communications and, energy, uh, I think there's a realization that, these things are not, siloed off. You can't really have a communications backbone unless you've got power for that communications backbone.
Yeah.
So, I think because cities are now looking at the smart, aspects, or you will, or starting to integrate a lot of these, digital assets, and understanding that they are interrelated and interdependent. I'm looking at this kind of convergence of, all sorts of different engineering and, science backgrounds that have to come together. And, that actually gives me some hope because, I think the more, generalists that we've gotten, in some respects, we've gotten very specific, and we kind of went through this period of having specializations, and you had to be specialized in something, to be, good, or, valuable to an organization. Well, now I think we're kind of going the other way on the pendulum and swinging to where you've got to be, almost a generalist across the board on many different things to actually provide that value, because things are starting to converge very, very fast.
Yeah,
And I know
that's
that wasn't a specific example, but
no, but well, hey, I'm always like, hey, not looking for, there's so much you can Google and say, cool. And you type in smart city and you'll say, there's this thing, a sensor. And I try to always remind people, you don't just go to Best Buy, buy something, or some other big box store, plug it in and say, hey, we're a smart city. There's a lot of science and engineering that has to go into
no,
that.
you have to
Okay.
understand what the physics is doing. You have to do that.
Amen.
Yeah.
Mark Gabriel, great man, CEO
Yep.
out at, yeah, always talks about the physics. So I shout out to Mark there. So I would be remiss if I didn't, while we highlighted Coyote, which again, cybersecurity for operational technology environments, folks. If you go to the energy.gov CSER site, it talks about R&D activities, or some document I read, and
Mhm.
there were other terms, other acronyms. And if you can, in your own Ed kind of way, wearing your professor hat, I read about cyber analytic tools and techniques 2.0, CAT 2.0. I read
Yep.
about the cybersecurity risk information sharing program, CRISP, and
Mhm.
good old C2M2, cybersecurity capability maturity models. Is there some way, shape, or form you can kind of differentiate why those are so elevated in every document I read and what value you believe they're bringing?
So sure, in no particular order. I mean, CRISP
Yeah.
is probably the most mature. And it's out there. It's actually not a DOE run program anymore. It was transitioned over to the EISAC.
Okay.
So they're actually running that. There's still some elements within the department to improve, the technologies, and that's focused basically from the perimeter of the asset owner's environment out. So I'll call it the internet data, if you will. Coyote, we talked about, is the OT, environment. CAT was really looking at the three, I'll call them realms of data. So you have the internet data, you have your IT data, your enterprise data, and you've got your OT data. And the IT world, I think there's, the enterprises, many of them have their own tools, their own capabilities to track down, their own, traffic, malicious or not, within their environment. So they've got a pretty good handle on that. But where CAT was focusing on was really kind of that intersection of all three. And would you be able to track something that started in the OT world, with a physical effect, and then go through the enterprise boundary, and then potentially even through, their own gateway to see, okay, is it going to a C2 infrastructure, that's malicious on the internet? And if we had that entire string, wow, that would be really successful. But one of the things I challenge the labs with all the time is, what can you do with imperfect data? Because that's what we're dealing with.
Yeah, I love that. And the imperfect data, there's people talk in the IT space a lot about the cloud and the volume, velocity, and variety of so much data. And then there's this veracity now that's been added. And again, I hope that folks understand that this is a complex ecosystem. The topic alone, we've covered a lot with Ed here, that's going on each and every day, 7 days a week and twice on Sunday, as I say. But boy, does it take a lot of orchestration. And Ed, you are, in my view, a champion of that. And I love your progressive and forward-leaning personality. And kudos to you, my friend. All right, there's going to be two more questions. Yeah.
So one thing, I would actually be remiss if I didn't mention another program, which is the consequence-driven cyber-informed engineering effort that INL has been developing over the past decade.
Oh, and talk to me. Go. I love the folks at INL.
Yeah, so basically it looks at, there's lots of interviews with the asset owners and saying, okay, what is it that you believe are the high consequence events? And there's, kind of this 4-stage approach to, really understanding their environment, determining what these high consequence events are, and then kind of distilling that down into, okay, what are the things that are connected? And then taking an adversarial point of view of how would I actually affect that piece of equipment or that process so that I can make a bad day, make that high consequence event actually happen. And then what are the mitigations in place? And some of the mitigations aren't necessarily in the digital world. They could be, moving a signal wire from, one port to another or one device to another so that it's not in the same channel, or, buying a smaller drum of chemicals, so, there's all sorts of, actually low tech solutions that you can actually implement or, to mitigate some of these cyber risks. One of the things that we've done with that program is move it, not completely away, but away from a manual, highly intensive process to now there's it's called accelerate training for industry, the asset owners. And, that's been fairly successful. And we're looking to move that out from necessarily the energy sector. And I believe we're actually getting some traction on moving that to other sectors. They might actually hear about that moving into, say water or, other things that are very similar, but under a different, SSA, sector specific agency. But, again, this talks about the fact that, the critical infrastructure has, similar components, so this CCD program is really looking to kind of exploit that, if you will, take advantage of the fact that there are, similar control issues across many, many different infrastructures.
Yeah, I'm so psyched you brought it up. And again, shout out to Zach Tudor, who I was out with, and Rob Pate, obviously yourself, Daniel Noyes. I had a wonderful visit last December. And if you've never been to Idaho National Lab, folks, it takes a bit to get there, but what an incredible, one of our national treasures. There's so much going on. And Ed, you brought up this, again, some of the themes we talked about in our prep calls were the importance of strategic partnerships and of course, R&D and how important that is, but the training and awareness. At the DoE Cyber Conference a couple of years ago, I was able to walk in a room and see what a control system looked like at a substation that had red light, green light, yellow light. And at the same time, there was, that's what you see, but look what the bad folks are doing. And that was so pictures worth 1,000 words, and kudos to the wonderful folks driving these programs. So folks, labs are not just folks with, pencils in their pockets and high waters, khakis, black shoes, and white socks. There are some amazing people who are cool as they come, millennial types that you need to go find out. And Ed, thank you for giving that a shout out. Okay, so Ed, thanks for the breakdown of those programs, by the way. Everybody go to energy.gov, read about them again, and take every opportunity to collaborate. I have mentioned a few things, and I'm going to do this, Ed, as you start to contemplate part of your parting shot, which is why somebody should care about a lot of this topic that we had for the day. But that's your final minute of our interview. Okay. I also am going to ask you a question just because I am, and it should be right on off the cuff, but it's going to be, if you weren't doing this, You've been in this space for 30 plus years. It's an incredibly impressive and diverse background. What would Ed Rhyne be doing if he couldn't be doing that? And that's going to be the first question I want you to answer. While you contemplate those two, folks, Presidential Policy Directive, Critical Infrastructure Security and Resilience, it's still a great read. The Guide to Industrial Control Systems, NIST publication 800-82 revision 2, a great read. The Multi-Year Plan for Energy Sector Cybersecurity, dated March 2018. A lot of what Ed has broken down for us, a lot of the vision and mission and the future state of our grid is there. The National Cyber Strategy, the Worldwide Threat Assessment. This is documentation that captures so much that Ed's speaking to, but you've got to involve yourself. You've got to read to understand, as good as our friend Mr. Ed Rhyne is in terms of breaking it down for us. Okay, so that's some shout outs. Eventually I'll get some pop-ups on these interviews and people can say, ooh, what did he say? But Google the stuff. Ed, if you weren't doing this today, what would Ed Rhyne be doing?
Oh, I'd be doing my, actual favorite job. As passionate as I am about technology, my favorite job is being a dad. It's awesome. So I just be doing that all the time.
That is great. No, I'm father of 4 and it's a blessing, but I love that. Humanizing you. Now on that, is there a hobby or two? I like to tell people when they say, tell us something about you. And our good friend Rob Pate would laugh when he heard this. I held the record for 39 years for the 50-meter breaststroke when I was 11 and 12, and it just got broken. So when I tell people that, it's like, wow, they want to talk about that more than what it was like being the CTO of energy. Is there a little nugget of something that Ed Rhyne is known for that is shareable?
Well, back in the day, I was swimming as well, breaststroke as well.
Whoa!
So got that. Yeah, absolutely.
All right.
Haven't checked on any records to see if they're they've lasted through the years, but
okay.
I kind of doubt it.
Okay. Hey man, I dig it.
Yeah.
All right. Cool. Yeah. Well, thank you. And again, I have 20 other questions, but I won't pull out my James Lipton of your favorite color. And what would you say if you were standing in front of the person above one day? We'll do that some other time.
Enough. Yep.
Yeah.
Right.
Hey, Ed.
Some two-phase fluid, perhaps.
Yeah. Okay. Love it. I love it.
Yep.
Ed. Okay. So this is the serious folks watching this today, tomorrow, or a year from now. What do you think folks should take away from the topic today? Mm-hmm. And what are some of the points you hope to leave with them and why they should care? What's in it for me is always a question I think people are thinking when they watch these highly technical discussions and interviews, like, why should I care? What would you say to those folks?
Well, so why should we care? Energy, all the critical infrastructures are, called critical for a reason. Our livelihoods are dependent upon them. And, if the energy goes away, if the electricity in your house goes out, for more than, a couple of days at a time, it's a bad day. And, I think part of the government role is really to prevent those from happening. And it gets back to this question of, are these, events that happen, take, an outage on the East Coast and an outage on the West Coast? Were those two things correlated? In other words, was somebody driving that to happen, or are they just coincidence and it's just a bad day? Either way, it's a bad day, but, there's degrees to it. And I think, if we realize, that determining that is not easy, and it requires, everybody to work together. And, kind of this one last parting shot, if you will, is, having a background that you can say, I'm good in this, but then having the curiosity and the ability to be more of a generalist as well. I think that's going to be key to, people's success going forward.
Well, words of wisdom from the great Ed Rhyne. Ed, thank you for being here, and we will do this again. Thank you for sharing, enlightening, informing, educating. Thank you really for helping those understand, or hopefully, that technology affects humanity, that humanity influences.
And it's the great equalizer.
Yes, it is. It affects, technology, never the problem, but it affects humanity, folks. It influences the culture that we live in, the country we live in, and then it shapes our culture, that is, the technologies we need in the future. And this gentleman right here and the folks he works with is helping drive that and protect it in the same vein. So Ed, great seeing you. We'll be in touch, and thanks again, pal.
Yeah, thank you. Thanks again. It was great.